Okay, so good afternoon. Welcome to Monday Live. My name is Anto Budi-Arjo. This is something that we do every Monday afternoon to try and figure out the future for smarter buildings. So glad that you can join us today. In case you are wondering who we are, our profiles are listed on mondaylive.org. So head over there. Just as a reminder, the views here are personal, not of any company or organizations. Keep that in mind. And please do post questions and comments on the chat to make this as interactive as we can make it. We do like to make this slide, sorry, repeating myself. Yeah, this slide deck is also available on mondaylive.org in case you want any of the links. Okay, so this being March, we have been since last week talking about IoT, the Internet of Things, and we're going to continue this conversation today. And after our normal news and trends, then what we want to do is to sort of compare sort of the typical IoT architectures to the architecture of sort of the cloud native architecture of the IBB that we've been talking about on Monday Live for a while. So we'll see how that goes and go into any discussion hopefully about that. Before we do that, just a programming note. Last month we talked about OT, and this month we're talking about IoT. So there's a bit of a progression here. And what we are sort of thinking is that this sort of leads to April when we intend to talk about AI, because almost the AI sort of needs for buildings, it needs to be based on OT and IoT or based on thinking about OT and IoT. So that's the progression that we're making. Looking forward to that. And over to Ken. What's going on, Ken?
Thanks. Lots going on. The main thing is the World IoT Day occurs on April 8th and 9th. I guess it's 8th, 9th, can't remember, can't see the number there. And I think this is a great opportunity for us to provide a summary. And if everybody is agreeing on Monday Live, I'll do that on automated buildings. I'll pull together the weekly sessions and roll it all up and put that in as our effort for World IoT Day. World IoT Day, if you don't know, you can click on it and find out more about it. But it's just a day to acknowledge the work that is going on in IoT. So it's a good pitch. We of course have just finished last Friday. We had International Women's Day. We had a good showing by a lot of folks, a lot of good interest, and I think we're starting to turn the tide. We're starting to get a lot of powerful women in our industry, and I'm really proud. And Roberta Tincher is actually Therese Sullivan has written this up, and Therese was originally involved in Monday Live in the early days of it. And it's a real fun article because I love the cartoon caption. They want me to clean up this mess. And it dawned on me is that Roberta's journey, as she carries it out in the interview that Therese presents, is really all our journey, is that we inherit this mess of computers and microprocessors, and we eventually have to string that out in some manner. And she tells how she's done that, basically following the Tritium and Niagara path, which is certainly a good way to do it. Inspiring inclusion, I think we've been fairly successful at doing that. Really pleased with the progress we're making. The last part that I wanted to point out is this AI is, I'm billing it as our way out of the closet, or out of the boiler room, maybe boiler room Bob thinking, or BAS is a closet industry. I think we are now moving to OT, and we're moving to become a an industry. We have to kind of pull ourselves together as an industry, and automated buildings is attempting to do that. Back up at the top of my slide, I say we are the industry that provides physical connection to building systems using operational technology. No matter how smart AI becomes, it eventually has to do something, and we're the people that do something. So it's going to have to go through us. So what's going to happen, in my mind, is OT, BAS, Boiler Room Bob, all of these things are going to become much more significant than they have in the past. So our route to moving out of the closet is to basically embrace AI and help them achieve what they want to achieve. And as a lot of the discussion today, I think feeds well into our April session on AI. So I think that's a good one. Anyway, the other one, I've posted the actual post that I put out, and I put this out on Artificial Intelligence Investors Group, and I got over 45,000 interactions, which is huge for our industry. And it's got good information on it. Paul Storm runs another magazine, which I'm happy to link to, because it certainly is a different subject matter than what Automated Buildings talks about. But I see that there's room for us to push information back. But if you look over on the right-hand side of the screen, he has around 600,000 followers on LinkedIn, and has over 50,000 subscribers on their newsletter. Now, obviously, this is all AI in all of its manners, but we are actually quite interested in AI in all of its manners. Is how AI is used in almost every stage of life. It will have an effect on us. How it's used in cars, how it's used in anything, is going to have some ripple effect back to us. So anyway, that's my observation, is AI is going to engulf us, but we will have a significant impact on AI. Back to you.
Thank you, Ken. Appreciate it. Sort of moving on. There you go. Just a reminder of the Smarter Summit video is available, and we are still working with Realcomm on what's actually going to happen at Realcomm in Tampa this coming June the 19th. So stay tuned to that, and take a look at the past summit or highlight. Some additional links here, as always. Note that I've added here an IBB office hour link, which is also linked from the IBB website, but just a way of getting there. If you find it interesting. Any other thoughts anybody want to share before we move on? Hearing nothing, we shall move on and talk about Internet of Things, IoT. And we really want to do a sort of a bit of a comparison of the architectures of IoT and IBB, and do a sort of a morphing sort of exercise. And as part of that, dig in a little bit more of into this sort of the uniqueness of IBB that may in fact help bring all of these things together, to sort of the grand bringing everything together. So we'll see how it goes. And we are going to be using fundamentally, as an example, an architecture of a system called eView IoT, which is from our friend Tracy here. So Tracy, I hope I don't say anything wrong. If I do, please do correct me. It should be pretty straightforward. Okay. So this is a simplified version of the architecture, and we think about this as an IoT architecture, because IoT systems typically have this sort of structure, and we'll spend a bit more about that. What Tracy has is essentially what he calls a web server, which is obviously a piece of hardware that's running on-prem. And these are typically, in this case, the product goes mostly to sort of smaller restaurant type properties. But again, the architecture should be similar. And so this web server is connected to a whole bunch of food safety, lighting, and energy devices using Modbus. And so it's reading data and it's doing whatever it is. And I don't know exactly where the logic is done, but there's some stuff that happens here in the gateway and some stuff that presumably happens in the cloud. It's probably a balance of the two, and we probably don't care exactly the details, but that's how it works. And the cloud component is the one that's also providing the UI on browsers. So that's a sort of a SaaS model of a way of using the web, this product. And you can do that obviously across multiple sites across the cloud, which is wonderful. On-prem, there is a terminal or a UI of some sort. Presumably that comes in as laptops and portables as well. But the on-prem UI is an on-prem UI that connects to the cloud as well, presumably as the web server itself. So this is how things work. And this is obviously a sort of an IoT system based on Modbus. But if you think about much simpler IoT systems, like a sort of a faucet thing that goes into restrooms, then you typically have a faucet that's connected to just a simple gateway of some sort, and maybe that's through Bluetooth or Wi-Fi or some other wireless, and then going directly to the cloud. That's maybe a sort of more typical IoT, smaller IoT kind of architecture, but structurally it's the same, right? Or similar enough to be the same. So have I said anything wrong so far, Tracy?
No, I think you're okay. Well, we can expand on some of the things when we get more into the conversation, though.
So the task is, how do we morph this into an IBB architecture? Right? And the first thing we sort of put here is that, you know, we sort of need to regard the screen as being split horizontally with cloud at the top and on-prem at the bottom, right? Just to sort of conceptually. Right? So how do we make this? How do we IBBize this architecture? So really the first thing to do is to think about taking that gateway software and out of the web server, right, into an IBB, again, in on-prem, right? So it's effectively just moving the gateway application from one box into another. Right? That really doesn't change anything. It doesn't change the architecture. It will still talk to the Modbus southbound. Obviously, you have to figure out how the wires get connected and everything else, which may be a little bit different, but structurally is the same. And it would still talk to the IoT, EVO IoT system in the cloud using exactly the same calls and everything else. And the software-wise, it probably wouldn't even know the difference, that it's actually different to the previous architecture, right? So, okay. And all of the different UIs that Tracy has, the SaaS base he has, all of that will still work just fine because we haven't really changed anything. And the on-prem would still work just fine as well. So that's kind of the step one, as it were. So let's sort of say, okay, so maybe we now start to think about things that some of the benefits that start to come from this architecture. Because in addition to the SaaS screens that Tracy may have provided, we can also connect this IBB to any of the IBB cloud platforms that the IBB is designed to work for. We've talked about this in several times, that the IBB is designed to work with a cloud platform that can be obviously from multiple vendors. So that can be there in addition to what Tracy's doing with the SaaS. It also changes what happens on the right-hand side here, because, you know, with IBB, we have this sort of notion that users are location agnostic, so it doesn't matter where. So the whole differentiation between whether something is on-site or off-site really goes away because it really doesn't matter. So that's kind of another conceptual sort of difference. So really what's going on here is that you can think about this as sort of an IBB cloud. All of these things are connected using a sort of the IBB framework, the IBB architecture. Which is great because this is where we start to be able to think about other systems that can be brought into this. And I've put a whole bunch of them just around the screen there. Everything from digital signage to social media to grid signals to dashboards or whatever, right? So this list is something that we actually talked about last month, a big long list of dozens of different systems what we potentially can integrate. So this is just a sampling of that. And you may also have similarly a sampling of other systems that Tracy was not previously looking after. Right? And again, some of these may use icons that's on the left. That's just me copying stuff, so sorry about that. But these are kind of, again, IP connected package units and other systems that are actually connected directly on the southbound of the IBB. Okay, so then the question is, how do we make all of these talk to each other and interoperate with each other? Yeah, that's kind of the question. So, and this is where we have this sort of connection profile mechanism that we'll talk about in a minute. But the first question that many people ask is, where does the code go? If we're going to implement something like connection profiles, where does it go? Where does code? Where do I write code? People kind of get hung up on that, and good reason for that. And so in this architecture, this is where code goes, right? These are kind of the symbol of coding, angle brackets, right? So code can actually go in any of the cloud provision systems. Obviously, those are cloud native by design. So code can go there. Code can also go in these devices because they are inherently IP connected devices that's connected on the IP network south of the IBB. But you'll notice I didn't put any code here because this is all Modbus LAN or whatever protocols is southbound. There's very specific southbound. In the case of Tracy, this is all Modbus. So there's no code here because the only thing these things don't know how to talk about is Modbus. But you'll see a code element here. Because really what's happening is this is the system that's looking after this, right? So connection profile is structured as a connection mechanism between systems. So it's always systems that are doing the connection. But it's always, quite often, it's always about devices, but it's always systems that's actually doing the connectivity. So that's kind of a strange little thing that you have to think about. So using this architecture, all of these codes that's running on all of these devices, when they were installed into the IBB or into this framework, and they could be multiple IBB brokers, obviously, in this architecture, they would have made declarations to the broker, right? Publishing or presenting their capabilities. Right. And it's from these capabilities that the broker says, okay, it makes a whole bunch of connections. And the connections get really messy very quickly because the connections go from wherever it needs to go to wherever it needs to go directly. And you'll notice here, that this connection is going from this one to this one. And obviously the code is the one that's sort of managing all of that. But you'll notice that I drew a line from here to here, even though knowing that there is no code here. And the reason of doing this is that the line is really talking about the business logic of what's actually going on. And what's going on is really a connectivity between whatever the supply chain system is and that particular device. That's the idea of the line. Even though this device is being managed by a system itself. So the connectivity is like the sort of digital connection is actually going between this system and that system, but it's about this system and its relationship with this. right? So all of these different systems that don't have interfaces themselves are all being taken care of by this entity up here. That is the system that's responsible for it. So that's kind of explaining that. So this being sort of really sort of complicated diagram, what I want to do is I want to dig into just one of these lines and explain how it actually works and what these lines are. So if you think about two different systems and a line between them, right? So this is exactly the same as what I had in the previous slide, just simplified. So what we're sort of finding is that really sort of the best way of thinking about this is that what's going on here is that this is a connection between two systems that is representing a common business interaction. Right? So let's just expand on that word a little bit. So the interaction is really talking about the digital interaction that we want to happen between these two systems, whatever it is, right? And then we also want to talk about the business purpose of these two systems communicating. Right, there has to be a business purpose, otherwise why connect the two, right? So there has to be some interaction, there has to be some purpose, and the third part of it, there has to be something that is done frequently, it's a common thing that happens over and over again. If it only happens just once in the lifetime of all of our lifetimes, it's not worth trying to standardize on it, right? So if it happens a lot of times, then it's worth creating a sort of a replication model for it, and that's what the common thing is. Right. So think about this line as a common as a common business interaction of something needing to happen, and you obviously you can take that back to this line, and you can start to imagine some of these lines. But basically, it's a business interaction. So when you put it into a sentence, a connection is based on a profile, and that's why we use the term connection profile, because a connection is based on a connection profile. It's kind of the model for it. And the connection profile is a repeatable template. We want the repeatableness of it, and we want it to be a template so we can use it over and over again to deal with this business interaction that happens over and over again, right? And it's always the same. So it's a repeatable template to achieve some specific business outcome, right, from the specific interactions about these two systems. That's what a connection is, based on a connection profile. Okay, let's dig in a little deeper. So what then makes a connection profile? How do you think about connection profile? So first thing is that connection profile has to have a clearly understood purpose and specification. Right? So an example here is something like get occupancy information. Right? That is a business objective. I need to get occupancy information from this building. Right? So that's the purpose. They also needs to be specifications of what does that really mean, right? And some business purpose can be really brief. Some business purpose could potentially be really sort of complicated, and that all needs to be in a specifications, typically in a specification document. So the first thing it needs to have is a clear purpose. The second is that connection profiles always happens between two systems, systems A and system B, right? They are not the same, because it's a get occupancy information that is going to be accomplished by these two. So one of them must be providing occupancy and the other one must be needing the occupancy, right? There is a sort of a flow that has to happen, right? And to make a connection profile, you need to understand these two roles. And the way we help doing that is we sort of think about them as providing and consuming roles. But when you create a connection profile, you can give that role a name. Right? So if this is a get occupancy center, I could make an argument that the thing that's going to, on one end of it, is going to be a sensor of some sort. Right? So we can call it the sensor. And the other end is going to be, I don't know what it is, but it could be a dashboard. It could be something that collects occupancy. So I'll call it a dashboard. So we give it a name. And then we define what needs to happen between the sensor and the dashboard, right? And think about this part of it as a contract. This common business interaction is also a contract. For this to occur, system A, the sensor needs to do things, and system B, the dashboard, also needs to do different things. When they two do their own, when they two provide the things that they're obligated to provide, then we have accomplished a task. That's why this is what it's all about. So there's a list that is required for both the two ends to provide. The last thing is that's required is a name. We give this get occupancy information a name, and the name has this kind of syntax: CP standing for connection profile, colon, and then the name is a sort of a dotted name similar to domain names. But it's not a domain name. You wouldn't find CNN.com here, CNN.com here. The domain, the profile names are a completely different namespace, right? But they have to be unique, and they work in a global basis, somewhat similar to what DNS works. So it's just the unique name, and it never changes. The other thing is that all of this gets applied at a specific context, right? Because all of this is very broad. It's the functions of these systems. But when you then apply it to, for example, an IBB, you're providing a context that this needs to happen, this IBB. So that is the kind of the application of a connection profile, is the point, is the context, and it's really the thing that then starts to extract the value in that particular situation. So really the way everything works is that when these systems initiate, or when they need to, they declare their capabilities. And when we talk about capabilities, it's really about the profile that they're able to understand, the role, either the sensor or the dashboard, and the properties they're obligated to provide. So they do all of that. They send their capabilities to the broker, and it is this capability that the broker matches with all of the other capabilities that everybody is sending to create these connections. And that's why it does it. It's very efficient at doing that, because it's all of the information is ready for them to deal with. So if you take this example up the top here, and we sort of implement what we've been talking about in this one slide, we then get this kind of thing, where this side is actually what in this application we'd call a sensor. So we have a sensor on one end, we have a dashboard on the other end. The purpose of it is to get occupancy information. There'd be a name for it, but I didn't go into actually giving it a name. And there are properties that both sides have to provide, as detailed in whatever the specs says, right? So the specs will say that the sensor is going to provide a property called value, and it will say 1, and 1 means whatever 1 means. And the dashboard similarly can have something like a mode, meaning I want live occupancy as opposed to historical occupancy, which could be another way of another use of that business function. Right. So this is a very, very simple connection profiles, but really all connection profiles should be simple by its very nature, because it's a building block. And it's a building block that then creates these sort of system to system connectivity that actually can be useful for whatever purpose is necessary. One other slide is this is just a screenshot of an actual connection profile. This is the simple demand response connection profile that we did for our work at AHR. It's basically the name of it. This is the title, the description, who created it, the link to the specification. This is what the two roles are. Server end, the provider end is the controller, the client end is a device, and this is some dates when it was created and it's active. The other half of the what a connection profile looks like this. This is the list of properties. There's a property called simple level that is provided by the source, and this is what it needs to have. And these are some other properties. Half of them come from the client, half of them come from the server in this particular case. But all of these will, all of this sort of the details of a specific profile will obviously change depending on what the application is. But I hope that this gives us a better perspective of how all of this comes together. And I will stop talking now. Tracy, did
Now
you?
we have questions. Go ahead. Say it again.
I was going to say, I mean, we started way from over there.
Yeah. Yeah. Yeah, it's kind of interesting. I don't think there's anything you know, very unique about this architecture and the way we put it together. You know, the other half of this that you probably have blocked out right now, but we're using available on-premise protocols, for lack of a better term, Modbus, Zigbee device protocols, right? Device level protocols, and we're bringing those together. And you know, the main function of that web server is moving data up, and then when there are commands to come down, you know, being the traffic cop and sending those to the right place. What's interesting on this architecture, though, this is its simplest form, and then when you add in those wireless devices, it gets a little bit more complicated. But there's another level beyond this where some of these devices in our system talk either directly to our cloud, so they don't go through the gateway. They're IP devices that, you know, are just pointed at our cloud. And then some of the devices that we have, not necessarily the ones shown here, but others, actually talk to the manufacturer's cloud directly first, and then we API the data over, you know, in the cloud. In this IBB architecture, because we do that, you know, in this kind of an architecture, it would be done top to bottom. The data would be available no matter how the data got there, right? And if you could go forward to the next slide there too, the thing that occurred to me, sorry, keep going, the one with the blue, all the blue, there you go. You know, this is not unlike email, right? When I send an email to somebody, I don't know what servers or what wires it goes through and so forth. And this is a little like that in terms of just conceptually, you know, you make a connection and you're communicating, quote unquote, directly with a device. And it's the same in email, right? You could be going through any number of different servers and switches and so forth to get email through. So it's not unlike that as well. But this is, you know, this is I think a good example because it's very real world. You know, when you're not a vertically integrated manufacturer who does its own software servers, all its controllers, all its sensors, you end up with systems like this. And it's kind of a mini version of what we're talking about when we talk about system of systems, right? We don't really care, you know, how they communicate or what their means of communication are, only that we have a mechanism to communicate and create those connections, in this case, connection profiles. So I think it's kind of a good example from that standpoint. Now I'll be quiet and see if anyone has questions.
Well, would love to get any thoughts either on chat or if somebody wants to join us on the conversation, just climb up. But Rick, Jim, Ken.
Dan, so can you give us a little more information on how I would find a connection profile? So say I'm an integrator and I'm looking forward to connecting devices using connection profiles. What's my next step to find out how I could connect my device using connection profiles to someone else's?
That's a really great question. And I think the way to think about connection profile from a user's perspective is that, I mean, we're drawing these to explain how it works and how pieces come together, right? But when you're actually in wanting to make something happen, I think there's two parts that I can think of, just sort of right out of the bat. One is that products that I buy should have their capabilities expressed as connection profiles. That would be one way of doing it.
Mhm.
Right. So you could we could end up in a situation where either a controller will actually be a provider of some example.xyz control of connection profile. In other words, that product, right, is got software in it, right, that can be a provider of that connection profile when that product is installed in a system that understands the CNSCP and the connection profiles, right? So in other words, you're not selecting the connection profile, you're selecting a product that has the connection profile. One good example for this is like demand response, right? If we had the architecture where the IBB has sort of the server side of a DR signal coming from the grid, right? Then what we want to the products that we want to install in that building should be products that comply with being a client, being the consumer side of that DR profile. So basically, what you would need to do is you would need to say, I want to make sure that product that I install have those profiles in them.
So
Right? So
I'm sorry, go ahead.
but that's kind of the product-centric approach, right? The other centric approach, I'll just sort of explain that, and you can chime in, is when you have a sort of a platform, like we're doing some work with Edge Central, right? Edge Central, like any other sort of integrated platform, doesn't inherently do anything. You have to, as an integrator, you tell it what you want to do. Right. So at that point, you would actually say, oh, okay, if I want this application, this complex application that I've created using Node-RED and using something in Edge Central, I want that to be a client of this DR because this building has a DR server in it. Then what I would do is I would say, oh, okay, I need that as a function of this Edge Central. So I would install whatever hooks is necessary to be a client of that connection profile, and then wire it up to how I want it to behave.
Interesting. So, when you talk about DR, or you talk about people sensing, or you talk about any of these other applications, you have a preconceived notion of what that application is already, which gives you a model, if you will, of how the different parties in that transaction need to behave, right? So I fundamentally have an idea already if I'm going to get a demand response signal and I'm a building, how I'm going to respond to that. If I'm running a quick serve restaurant and I have people counters measuring the flow of people through the drive-through or through the rest of the restaurant, I have a preconceived notion. How do we construct these connection profiles for applications where we don't necessarily have a preconceived notion yet? How do we bootstrap our way into figuring out flexible ways to represent the ends so that people can maybe go beyond the scope of the obvious?
Let me build on that a little bit. If we were fast forwarding to when all of this was in place, kind of top to bottom in the stack, would a device manufacturer who makes a thermostat, let's say, and wants it to be IBB compliant, publish its profiles, just like I publish. If I wanted to have a conversation with Jim, I'd give him my email address or my phone number or whatever, right? It's kind of no different than that from a device standpoint, I would assume. And then there's the architecture in place in the cloud. This is the part I'm still a little fuzzy about, but the broker piece of this that manages putting all of those things together, right?
Right.
So if there's kind of two ways to think of this. One, you can think of it like a Google search, if you just want to go out and see what's available, there needs to be a service to say, here are all the available connection profiles. You know, you can go in and search to those and subscribe to them and so forth if they're appropriate. Or it's something more like an email system where, you know, you need to have somebody's email to communicate with it. And I
Right.
think there are elements of both in this. Is that correct?
I think so. I mean, I find this really fascinating conversation because this is new. So I don't really know. I'm not sure anybody knows the answer, right? So
Yeah.
this is great. I mean, I think we'll know the answer when it sort of appears, because it will be sort of straightforward. But you know, I see potentially a product data sheet down the road will have a section. I mean, it will have sections as to power and, you know, communication protocols, whatever. It could have a section that says supported connection profiles, and it will just have a list of them, or it may be digitally done because it may be a long list, depending on what it is. But you could do that.
Yeah,
Right.
I mean, it's like a business card today or a landing page on a website. You know, here's my Facebook, here's my Instagram, here's my LinkedIn, here's, you
Yep.
know, and so on. And it's just another one of those
Exactly.
for a device.
For a device. And then conversely, on a specification, and this goes back to things like 2525, right? There's nothing stopping an owner of saying that everything in this building should be able to talk to a DR server, OpenADR3 server, let's say. That's their specification, right? Then therefore, any device that gets connected to this architecture must have a certain connection profile as a client. That's another way of doing it. That's sort of early on the chain, obviously.
Well, I think the thing that I'd like to point out to everyone is that the connection profiles are really a business relationship between things. We're using other things that have already been implicitly determined. The English language, BACnet, LawnWorks. These other pieces down below aren't necessarily changing, but the connection profile is really going to represent the business reason and the reason to communicate business information between the different systems. And it might be other information as well, but it's primarily a methodology of doing system to system work. And I think that, I don't know if I can make that clear, that there's a differentiation between just having a communication protocol, data definitions, metadata definitions like Haystack. None of that goes away when we add connection profiles, but connection profiles give us a way to work system to system between these different devices.
That
Well,
are not likely to have a common transport protocol between them, because they're likely to be in different domains.
Yeah. I know in past conversations we've talked about, you know, why would somebody want this? So when I look at even the eView system that you were talking about, buried in and amongst those devices is a lot of data about specific equipment. So for instance, I could tell you, you know, how much runtime any particular RTU on our system has had over the past year. How many, we don't log maintenance tickets, but it'd be a real easy integration to log that, or IBB connect that to a ticketing system, for instance, and tie in, you know, trouble calls or maintenance along with that. So you start to really accumulate a little bit more information as opposed to data, right? How many hours, you know, mean time between failure kind of information for RTUs, let's say. Walk-in freezers with that refrigeration controller, freezers and refrigerators, same thing. what are the average set points? What are the rates of recovery? How much runtime, are those compressors seeing over some period of time? All of that data would be available. Well, that could be kind of interesting to people who are manufacturers of that equipment who otherwise wouldn't have that information about their units. That could be really useful to a system integrator who is going to sign a new maintenance agreement with a location if he knew already historically how well those systems have been running, right? And now he has that information to produce a quotation or pricing for a maintenance agreement, for instance. So there you start to find little bits and pieces that otherwise wouldn't be available unless you were able to get to this data somehow and make it available. That's another piece of this whole thing. I think it's important to understand.
The other sort of really sort of interesting angle is that, and you sort of reflected on that, Tracy, is that people tend to say things what you just said, right? I look at this system here, and it has these 700 pieces of data, right? You kind of know that this 700 pieces of data is going to be useful to somebody, but you have no clue.
Right.
As a manufacturer of that piece of equipment, you probably have no clue. Right. And it may well be that 3 of those pieces of data used in a connection profile could provide occupancy information, for example. So it could fit in this. Right. So the one of the things that connection profile sort of teaches us to do is don't think about what you have, think about what you can do or what you need to do. If you think about what you have, you can say, I have 700 things, right? And you can look at me and say, you're crazy. I have no idea what to do with that information. But I can tell you, I can provide occupancy information, right? That you don't care how I do it. You don't care the exact mechanics. But if I said that, and I said that in the context of a specific connection profile, you know exactly what I mean. So does everybody else.
To me, there's a huge field of dreams aspect to this, right? Build it and they will come. We used to say that when we were first trying to explain why you would want your BAS systems connected, all your devices networked and so forth. Well, we don't know yet completely all the things that people end up doing with this. And we're rapidly approaching now where we can't imagine deploying a control system and not having it connected somewhere somehow, right? Wasn't that long ago where that was the norm. So that's because we've learned the benefits over time of having remote access to all these devices and these systems. So I think there's a big element of that here. We can't imagine yet the applications that will be created once people have readily available access to this kind of information, this kind of data.
Yeah, I think the innovation, that's always the case with technology. You just the unintended consequences. Once there's a technology that's made widely available, these creative, industrious, innovative people go, oh, wow, I could take this and combine it with this and do something that's never been done before. That's going to be exciting because the discoverability of the different capabilities and the assets is going to become universally more, just easier and faster. But the other thing is the stuff that we do know how to do that we'd like to be able to do in a more efficient manner. It's like right now we're not optimizing very many building systems at all. We know how, but it's too expensive right now. Or, so we only do it on we were going to talk about Internet of Things, Anto. One of my favorite things with the chuckle line is that right now we're on the Internet of Expensive Things. And what the new world will allow is for us to apply the benefits of Internet of Expensive Things to the Internet of all things. So we're already practicing with the expensive stuff. And we're using technology to optimize our best buildings and our most complicated buildings, maybe, but we're not going down and doing it with every building. And so that's what I mean by, we know what we would like to do for some of the buildings, and then there's going to be the innovation, certainly, but there's some really, really mundane, normal things that we should be doing to all devices and all buildings and all things. And so it kind of works both ways. But the other thing I like to say is that, Moore's Law has been in effect, and Gordon Moore just died, this past year, but his laws will continue to go on. And so the innovation that'll happen a decade from now in terms of the cost of the devices and the power of the devices and the ability to run more code locally, as Anto was showing, that's just going to get better and better. So having this new way of being able to find those assets and be able to innovate around this new capability, it's not slowing down, is what I'm wanting to say about that.
I think the other thing too is very quickly, as we start to lay out examples of what the connection profiles can do, AI will be watching us and will learn from us. And this mass amount of information is probably better dealt with by AI than it is actual humans. So it'll actually take a look at, you've created this relationship there. You seem to think that's a good relationship. It's logical to create that relationship here, there, and do a bunch of things with it. And as I say, I see us being an integral part of AI, because AI, all it does is think. But when it comes to doing, we're the industry that does. And so I think that's an interesting concept, that hot on our heels is, if we show AI how to do this, it'll figure out a better way of doing it.
Well, in unlocking the data points is a key thing, and it kind of goes back to my point. Is like Anto said it also, is like some of these devices that we're already deploying, they do have 700 data points in them. There's a thermostat that we did that had 640 BACnet points, and only a couple of those points actually get used in the current way things are done, because everything's been constrained, right? So to do the API or to route everything through a building automation system, as wonderful as they all are, was expensive. $1,000 or $5,000 a point to be able to map a point. So you lived in this constrained world rather than so instead of abundance, a scarcity mentality. So we do as little as possible because it's so hard to do what we'd really like to do. It's so expensive. That's all out the window.
We started this whole thing about IoT versus IBB comparison. One of the things, I'm not sure if it got mentioned, but it's worth repeating if it was, a typical IoT system these days, at least, tends to be proprietary or standalone and communicate only with its cloud. I mentioned in our architecture, there are devices that the manufacturer won't let us repoint where it's communicating, right? It only communicates to their cloud, and then we have to do something with it. And that's a typical architecture. So moving forward in the industry, things like IBB that make things more interoperable and available, I think is a normal evolution of today's IoT to what does IoT look like in the future, right?
It could
This
also
is just a method.
Yeah, it could also help that guy, the company that didn't want to change his architecture, right? One possible scenario is that product could be, that company could be influenced to implement connection profiles in that product, so that they can change the behavior of the product depending on what's needed, kind of thing, right? So that he may be open to, because it may actually have other value other than whatever, you know, the one unit that you may want to buy for that particular application.
Yep.
As the hardware completely disappears and all this becomes cloud native, then the economics completely change. And we're able to do more things. And if we can have AI help us, because now we're dealing with huge numbers, that's going to evolve extremely fast. And as to the can't say that word, the cloud that nobody can get into, that'll get changed
Proprietary.
because proprietary, that's it, the proprietary cloud. The problem, that'll get changed because the new competitor will come up and he will support the connection profiles and it show the flexibility, and that'll become the preferred product, and you know that evolution will go on. I mean, that's generally how we've been able to change the industry.
And you could foresee people competing based on profiles, right? Company A saying, I've got these 5 profiles, and company B says, oh, I've got those 5 profiles and 17 others that's even better. I'm not sure it's a numbers game. It definitely is not, but
There
you
is
can
an
see
underlying. Sorry, Anto.
I'm done.
There is an underlying business model here that is tried and true already today. We all have heard how some of the big guys like Google and Microsoft and Cisco, even Cisco, you know, they're all about increasing the amount of data that's flowing and or collected, right? This is no different, right? If a proprietary manufacturer doesn't want their stuff out there, well, they're going to miss out on the general population who is looking for that information. And somebody is going to find a way to get that to a place where it is. So I mentioned we're using APIs cloud to cloud because that's what we had to do to adapt to this. But we're getting the data to a place where we will make that available, even though it had to kind of route through a proprietary way for a while. So we're aggregating that data in a place where we can make this available, right? And that is very much what a Google would do in terms of collecting data and being the keeper of that data, so to speak. So,
and I think there's
a parallel
model for the distributor, the distributor function, because there's a bunch of those systems that are on the bottom that are the dumb system, and as a distributor, you can add value as an MSI/distributor by insisting that the products you carry are discoverable in a new way, and or write the code yourself, you know, add value to your distribution model by the fact that if you buy stuff from your catalog, it's immediately discoverable and then orchestratable. So it's going to be some really interesting innovation.
for sure.
That's cool. So we're at 4 o'clock here. Jim, do you want to wrap this up and what you learned this top level?
Well, I think, obviously we're looking at how IoT and the cloud go together. And Anto has made a nice presentation on connection profiles. And fundamentally, this work is developing right now, but I think it's a very interesting methodology for this system-to-system business contract type communication, which I think is going to be very important in the future. How some of the details developed, I think we all need to stay tuned and welcome more information on it. That's it.
Great. Thank you. Thank you all. Thanks everyone for joining us today. I hope everybody has a good week, even if it's a spring break. Have fun. We'll get the video up tomorrow, Wednesday, and we'll see you back next Monday. Thanks all. Bye-bye.
See you all soon. Bye.